Okay, I'm just sticking with the principle of conservation of linear momentum in this question, and I'm going to look at just another example here. Remember, we said the principle of conservation of linear momentum, PCLM, states that the total momentum before impact will equal to the total momentum afterwards. Okay, and we're talking about immediately before and immediately afterwards, instantaneously before and instantaneously afterwards. So suppose I've got two particles. A has a mass of 5 and a velocity of 10. B has a mass of 6 and a velocity of negative 5. They travel on the same horizontal line, and they collide. After collision, the 6 kilogram particle moves with a velocity of 2 I hat. Find the velocity of the 5 kilogram particle. Find the impulse imparted and the total loss of kinetic energy. So a few different things in here. I'm trying to think about exactly what's going on here. I've got some kind of object moving along a horizontal line, and I have another object also moving along the same horizontal line. Notice particle A has a velocity of 10, which means it's moving to the right, assuming, of course, I'm dealing with a right positive system. So particle A moving to the right at 10 meters per second. Particle B is moving to the left at negative 5i at 5 meters per second. And if they're on the same horizontal line, of course, they're eventually going to collide. And we want to figure out some stuff about what happens after collision. And we're going to use the principle of conservation of linear momentum. We're also going to use impulse. Remember, we said impulse is defined as being the change in momentum. So to find the impulse, we're going to find the change in momentum on each particle, and then we're going to find the loss in kinetic energy. So quite a bit to get through in here. Okay, so the first thing I'm going to apply is the principle of conservation of linear momentum, which says, and do write it out. I'm going to cheat a little bit here by just dragging this down and writing it out there. So that's my principle of conservation of linear momentum. It says the total momentum before impact is equal to the total momentum after impact. So all I'm doing here is just substituting in values and solving the equation. So total momentum before is equal to total momentum afterwards. So particle A, mass 5, velocity 10. Particle B, mass 6, velocity negative 5. The negative is important here. We're talking about velocities here as opposed to speeds. So substituting in, the mass of A is 5, its initial velocity is 10, plus the mass of B, which is 6, times its initial velocity, which is negative 5. Be careful with that negative. Lots of people will leave that out. Is equal to the mass of object 1, which is 5, times its final velocity after impact. The 6 kilogram particle, well, that's the second particle, isn't it? 6 kilogram. That's particle B. So the mass, we don't know. We're trying to find the velocity of the 5 kilogram mass. So we're trying to find that velocity of the first particle, plus the mass of the second particle, which is 6, and the 6 kilogram particle moves with a velocity of 2. Okay, moves with a velocity of 2. So a couple of things to note there just before I go on. And again, you really try to think about this in a general kind of way before you do anything else. Let me just take this down here. Oh, do that. Try that again. So initially, the first particle here was traveling to the right, second particle is traveling to the left. After impact, this particle here is now traveling to the right. It's turned around. The force of the impact has made that particle turn around and go in the opposite direction. How do I know that? Well, I know that because it's now moving with a positive velocity. It was moving with a negative velocity, so it has turned around in that instant. Simplifying here, that's going to be 50 minus 30, which will be 20. And that's going to be 5 times whatever that first velocity is, plus 12. and from here on in, it's just straightforward algebra. Subtracting 12 from both sides, 8 is going to be 5 times the velocity of the first particle. So the velocity of the first particle is going to be 8 divided by 5, which will be 1.6 meters per second. Notice it's positive. So the first particle was moving to the right at 10 meters per second. It's still moving to the right, but it is slowed down because of the collision. Second particle was moving to the left at 5, and then the force of the impact not only slowed it down, but actually made it turn around and go in the opposite direction. Find the impulse imparted to each particle. The impulse imparted to each particle. Let's look at the 5 kilogram particle first. Impulse is defined as being the change in momentum, which is going to be the final momentum, m1v1, minus the initial momentum, m1u1. Notice you can factor out that m, and it's just going to be v1 minus u1. So it's the mass of the first particle, which we know is 5, times its final velocity, which we know is 1.6, subtract its initial velocity, which was 10. Okay, and that's going to be 5 times 1.6 minus 10. That's going to be a negative thing. 1.6 minus 10, I think, is 8.4. Multiply that by 5. I think you're going to get 42. So this is going to be negative 42 Newton seconds. That's the impulse imparted to object 1. In other words, it's negative. The impulse imparted is in that direction on object 1, which makes sense because object 1 collided with something on the right, so the impulse is going to be pushing it back to the left. Now you do the second part over here. I want to find the impulse imparted to the second particle, so the 6 kilogram particle. And again, we've said that the impulse is change in momentum, which is the mass, times the difference between the final velocity and the initial velocity. The mass of the second particle is 6. The final velocity of the second particle, we said, was 2. Subtract the initial velocity, which was negative 5. So 6 times 2 subtract negative 5. That's going to be a positive 42 Newton seconds. Note that that impulse is positive 42. So the impulse imparted on object 2 by object 1 is equal, but in the opposite direction. And that's always going to be the case. Notice one will be positive, one will be negative, opposite directions, but equal in magnitude. Find the total loss in kinetic energy. Find the total loss in kinetic energy. Well, to find the change in kinetic energy, what we look at is, and again this is something I looked at in the last lesson, it's m over 2 times v squared minus u squared for each particle. So if I look for particle 1, for the 5 kilogram particle, it's going to be its mass 5 over 2 times its final velocity squared, that's 1.6 squared, minus its initial velocity squared, 10 squared. And you can plug that into a calculator if your mental arithmetic isn't up to scratch. I'm going to plug it into my calculator. 5 over 2 times 1.6 squared, subtract 10 squared, and that is equal to negative 243.16, sorry, just 0.6. And my units there would be joules. So that's the total change in kinetic energy. What that means is object 1 has lost 243.6 joules of energy in this collision. If I look at the change in kinetic energy for object 2, again, using the same formula, m over 2 times v squared minus u squared. Object 2 had a mass of 6, so we're going to get 6 over 2 times its final velocity squared. In fact, we're dealing with speeds here, so it's 2 squared minus initial speed squared will just be 5 squared. Or if you want to put in negative 5 squared, that's fine. So we're getting 3 times 4 minus 25. And again, you'll see that's also a negative. That's also a loss of 63 joules. So the total loss in kinetic energy, so the loss in kinetic energy is going to be the sum of those two things. And if I add them, I get negative 306.6. The loss, the negative is telling me it's a loss. So the loss in kinetic energy is 306.6 joules in this collision. Okay, so that's my loss in kinetic energy for the whole thing. So another example on the principle of conservation of linear momentum, making sure we're getting used to these words: impulse, kinetic energy, all this kind of stuff. Okay, so practice, practice, practice.